So let's start with the SR-7. So let's talk about the relevant specs. So previous to this, these specs were essentially unachievable. So prior to the Ox cart, which is the predecessor to the SR-71 and the SR-71 platform as it was a production, there were no aircraft, no production aircraft that could exceed Mach 3, and that's production aircraft. Those in use for espionage and intelligence gathering. Prior to this, the U-2 also flew at roughly about the same altitude as this, but also not at the same speed. Mach 3 plus. Um, I think it holds a record for Mach 3.3, but talking to some of the pilots that have flown it, said that it'll go much higher than that. Consequently, this is also the first stealth aircraft. So the first production stealth aircraft that used RAM coding, which is a little liner note that I didn't until recently actually know. So to sort of outline what they did, and this is how holistic engineering sort of works. So if you look at it, there's a list of these overlaps. There's a list of shared energies and a list of shared components. So first one that's notable is the symbiotic propulsion and airframe. So the J58 engines were mounted in the airframe, but didn't contain the intake spike bypass door and the exhaust. So those were all airframe components, but they were also used in the J58's function to improve its thrust characteristics throughout the entire operational range. So all the way from subsonic, from 0 to 3.5 Mach. These components, the intake spike, the bypass doors, and the exhaust nozzle, were all designed to work in concert with the J58's individual components to add performance that didn't exist previously. So, and of course, the J58, the turbo ramjet, this is sort of, I kind of already outlined this, is on the next slide. I'm going to go into this a little bit more detail, but not too much. Thermal expansion to seal fuel tanks. So they knew that at those high speeds, that the increase of temperature on the skin of the aircraft needed to be both dissipated and it needed to be accounted for. So this is where you kind of get into this operational holism, where you understand the entire platform together as one whole. They created a fuel tank that, understanding because of that coefficient of thermal expansion due to that increase of temperature, they designed it specifically to seal once it heated up. So we didn't have any buckling of the airframe and any buckling of the fuel tanks. And if you've ever watched any videos or seen any pictures of these on the ground, they would leak like a sieve, and they would leak all over everything. But that wasn't the case when they were actually at the operational velocities. They also used fuel as a coolant and also engine fluid. So I think they were using it for some. I think at one point they were using it for some hydraulic operations, but they also use it as a coolant for various system components within the aircraft. So some of the intel gathering cameras, some of the other ancillary systems that were inside the aircraft, they were actually using the fuel as a coolant. The airframe, again, on top of the airframe being a portion of the propulsion system, there's also additional performance increases of lift and aerodynamic efficiency due to the chines in the blended wing body. So this is one of the first production uses of that sort of mentality, where they basically were Kelly Johnson and team stepped back in Skunk Works and said, we need to get to this place. We have this particular energy nucleus, which they designed. So they also took the specifications, folded it back on that energy nucleus and said, hey, we need to specifically engineer this fuel for low volatility because of the increase of temperature, but we also need to have it perform dual function. And then with that understanding of that energy nucleus, they could now capitalize on it to produce a high amount of thrust per given energy, and also a high amount of lift and reduction of drag per airspeed by using this approach. So what you actually saw in this entire system was all of the components were thought of simultaneously. So when you were looking at this, you had a spec list, you had an energy nucleus and an understanding of those characteristics, and then you basically put everything in one box and designed specifically to all of those elements simultaneously. And then you had an emergence of all the components.